All right, so let's go over some problems. So the decimal problems. Number one is 0.3 less than 1/3? So I'll give you some time, pause the video, and try the problem. All right, now that we're back, let's go over the solution for number one. So I'll write that in red. So is 0.3 less than 1/3? Well, let's see. What is 0.3? 0.3 is just 0.3. If we convert that to a fraction, it's not repeating. It's just 0.3, so that would be 3 over 10. All right, and now we have that compared to 1/3. So which one is bigger? Well, the way we can compare these two fractions is by multiplying, cross multiplying. So we have 3 over 10 and 1/3. To compare the fractions, we can just take 3 times 3, which is 9, and 10 times 1, which is 10. And since the 10 is on this right side, that means that 1/3 is bigger. Okay? And another way you can see that is just by taking the 1/3 and converting that to a decimal, which is 0.3333 repeated, or just 0.3 with a bar on top. And when we compare this to just 0.3, we can see that 1/3 is bigger than 0.3 because 0.3333 is bigger than 0.3. So I would say that this is true. All right, and if you plug this in your calculator, you'll get the same answer. But a neat way to compare two fractions is by cross multiplying like the way I just did. All right, so now number two. Number two is asking, is 0.9 repeated equal to 1? So I'll give you some time for that. All right, so let's come back and check out and see if 0.9 repeated is equal to 1. So this is a very interesting problem. The answer is yes, even though it does not look like it, because 0.9 repeated is just 0.999 going on forever. It's some number. So I'm going to show you a proof that shows or proves that they're equal. All right, so let 0.99999 repeated equal a variable. Okay, I'm going to call that variable x. And now I'm going to take that variable and multiply it by 10. So then we get 10x. All right, and I'm just going to write it on the right side. So 10x would be x times 10. So what's 0.99999 repeated times 10? Well, that is just 9.99999 repeated. And before I continue, the way to see that, if you don't see that already, is whenever you have something multiplied by 10, you move the decimal place to the right. All right, so then we have, let's think of some number. Let's think of 0.3 like we had before. 0.3 times 10 would be 3 because we moved this decimal point to the right one place. And if we have 0.3 times 1,000, we move it 3 decimal places to the right. All right, so now that we have that under control, let's take a look of why these two are equal. All right, great. So I have these two numbers, 10x and x. So 10x and x. What am I going to do with that? I'm going to subtract. So I'm going to take 10x and subtract 1x from it. Now, we know that 10x is equal to 9.99999 repeated, and 1x is just equal to 0.99999 repeated. Well, one thing is interesting here. We see that there is a similar part of these two numbers, and that part is these repeating nines. So when we subtract them, those go away. 0.999 repeated minus 0.999 repeated is just 0. So this part of the number subtraction is equal to 0. And then what's 9 minus 0? That is 9. So we have 9.0 here. All right, great. Now what do we have on this left side? What is 10x minus 1x? Well, if we have 10 things, subtract one thing from it, we get 9 things, all right? And we'll go over more with variables later on, but we have 9x. Now, let's rewrite this down here. So what is it saying? It's saying that 9x is equal to 9. If 9x is equal to 9, then what is x? In other words, 9 times what equals 9? 9 times 1 equals 9. So that means x is equal to 1. All right, so if x is equal to 1, then we just proved that 0.999 repeated is 1. Because remember, look up here. Look up here. We have 0.9 repeated, which are right here. 0.9 repeated is equal to x. That's what we said in the beginning. So now that we just found that x is equal to 1, so then we know 0.9 repeated is equal to 1 as well. So here's our conclusion. 0.9 repeated is equal to 1. Yes, that is true. All right, great. So now we'll just do one or two problems concerning or relating to real numbers. All right, so just one problem I have. It says that it gives us a real number line, and it's giving us a couple of regions. All right, the region from 1 to 2 is A, the region from 0 to 1 is F, the 0 from -1 to 0 is B, and the region from -2 to -1 is C. And the question is, which region is radical 2 in? Radical 2. Which region is that in? So I'll give you guys some time. Why don't you pause the video and try it out? All right, now that you're back, we know we want to find what the square root of 2 is. So square root of 2 is equal to 1.41421, and it goes on with numbers that do not repeat, so we can't say that this is a repeating decimal. This is what's known as an irrational number. We went over this before. This is an irrational number. All right, so if this is 1.4121, then that would be between 1 and 2. So this is in 1.4121 is in region A, or area A. So that is our answer. The answer is A.
Take a full GRE practice test right now, completely free at argoprep.com.